All right, earthquakes, kids. It's earthquake week. Earthquake, a vibration of the earth. It's really not that hard of a definition. So there's parts of an earthquake are, the epicenter is where we say, oh, that's where the earthquake happened, there's the epicenter. But really, below the epicenter, deep down in the ground, sometimes 25 miles down, sometimes more, is called the focus. So the epicenter is up here on the surface with us. The focus is below the ground where the earthquake is actually centered, where the earth actually ruptures, fractures, and moves. And so the epicenter up on the surface, focus down below. That's earthquakes. So I should keep this just close by so that I don't have to keep moving around. The earthquake creates a rupture, a broken piece of land. It's called a fault. A fault line is the line along which the earth ruptures. The center of the fault line is the focus. The epicenter is above that, and there's no fracturing usually on the surface of the earth where the epicenter is. It's down below. The fault line can come all the way up to the surface, but it's never at the same point as the focus of the earthquake. So there are three main types of faults. Okay, so three types of faults. Faults break the earth along flat surfaces. And the flat surface sometimes is vertical, but very rarely. It usually slides this way or slides this way for a fault. A normal fault, the earth ruptures and pulls away this way and falls down, so it looks like the rocks slide that way. A reverse fault, the rocks are sitting there and one of them, they get pushed together and it slides up this direction. That's a reverse fault. And a thrust fault leans over really far, and it's an extreme version of a reverse fault. And then there's the strike-slip faults, which if they're like this and it fractures this way, they slide this direction. So normal fault, one part of the earth moves away and falls down. Reverse fault, one part of the earth slides up the other side. And a strike-slip fault, the two sides slide past each other like that. So there's three types of faults that we have that we normally talk about. And then, of course, just a thrust fault is a specialized reverse fault, which is a much more extreme angle, and they move much faster. Earlier we talked about P waves. P waves, S waves, earthquake waves. These are seismic waves. Now, there are other types of waves called surface waves. Two main types, Love and Rayleigh waves, but we're not going to talk about Love waves or Rayleigh waves. That's not part of our topic here. P waves, primary waves, arrive at the seismograph first. S waves, secondary waves, arrive at the seismograph second. P waves can travel through solids and liquids. S waves can only travel through solids. These are the things that I taught you earlier a couple of weeks ago. Oh, hey, the bell. Does somebody else have a ringing in their ears too? So a P wave is a compressional wave. I did not teach this part before, but I do want you to know. A P wave is a compressional wave, just like a sound wave is. The air compresses and travels in a compressed form to your eardrum, which compresses the eardrum, which causes you to hear sound. It's a compressional wave. Well, these P waves, they travel the same way through the earth. They compress the earth particles together and move and vibrate like this: compression, refraction. Anyway, but an S wave is a longitudinal wave, which is the kind of wave you think of when you shake a rope up and down or side to side. It's that sine wave kind of a wave. That's an S wave. A P wave is compressional. It's not the type of wave you think of when you think of waves, but an S wave is that kind of classic sine wave shaped wave. The Richter scale, the scale by which we measure earthquakes, is a reading of the power or the strength of a wave's motion on a seismograph, a very specific type of seismograph. The Richter scale is very good for telling us how much vibration the waves have if the earthquake was close by. Then we adopt it, and the Richter scale is what everybody on the news always says, oh, on the Richter scale it was a 9.5 or a 7.4 or a 2.6. Well, the next scale that they tried to use was called the Mercalli scale. The Mercalli scale was measured instead of 0 through 10, because the Richter scale, a 10 on the Richter scale splits the Earth in half, basically. In the Mercalli scale, it's 0 to 12, and on the Mercalli scale, a 12 rips the Earth in half. The Mercalli scale measures how much damage is done to properties. So, if a fence leans a little bit, that's a 2 or a 3 on the Mercalli scale. If your windows rattle, 2 or 3 or 4 on the Mercalli scale. If damage is done to weak structures, 5 or 6 on the Mercalli scale. If damage is done to strong structures, 7 or 8. If damage is done to reinforced structures like concrete structures, 9, 10, or 11. If massive damage is done, 11 on the Mercalli scale. And if the Earth cracks in half, it's a 12 on the Mercalli scale. Then we came up with the magnitude momentum scale, which is the scale we use today. Now on the news they say, oh, it's an 8.8. Well, that's a magnitude momentum rating, but they say Richter scale because everybody knows that one. Right? It's still a magnitude momentum scale. Magnitude momentum is the energy released by the earthquake in joules, which is billions and billions of joules. 1 joule is like enough to keep a light bulb running for 1 minute or something like that, or 1 second. I can't remember. It's something very simple. And billions of joules are released during earthquakes. Earthquakes, it's a ridiculous amount of energy. And so the magnitude momentum scale is actually a measurement of the energy released. It's actually a physical measurement of energy. So it's a more accurate scale. Also, the magnitude momentum scale can be used from any distance. No matter how far away the earthquake, you can measure on the Mercalli scale the proper rating. The Richter scale, you have to be really close. The measurements have to be done up close. And the Mercalli scale was a little better. You could get a little bit more distance out of it. But the magnitude momentum is a much better scale. So let's see. We got earthquake, focus, epicenter, P wave, S wave, fault lines, normal fault, reverse fault, strike slip fault, Richter scale, Mercalli scale, magnitude momentum scale. So we've got a lot of stuff about earthquakes. What I would love to do right now is put up some images of fault lines and just photographs, not cartoony images, actual photographs of fault lines, and describe in words. But I'm not going to stand here and talk about it and point to nothing. I'm going to put the image up and I'm going to write words over it to describe the fault lines, and then go into there will be some images of the focus and epicenter as well. So I'm going to try and get all of that put at the end after I'm done talking, which is right about now.